since 7th, 8th grade, right? And we've added new tools to our repertoire as we work through these things. AC, if you go to password, that's where it'll be. Or not AC, if you hit password, it'll be there. Okay? And so I want to caution y'all, and I want y'all to look over here in front of Dalton, okay? What did Dalton write that I circled that we need to pay attention to? No, that's not what I circled. X2 minus x1 divided by y2 minus y1, except I need y'all to be careful because that doesn't even say x2 minus x1. What does that actually say? X squared minus x to the first divided by y squared minus y to the first. Remember, if you put it as a superscript, that's a power. So be careful about that, right? It has to be where the values are subscripts like this, okay? When you put it as a superscript, that's what it's called. When it's above, that's a power. It's got to be a subscript. Second, always, always, always go back to the key ideas of what you learned first with slope. How did we first learn slope? We looked at, Walter, what did we look at first to find slope? Yes, but what was the term that, or the terms you used? Rise divided by run. Okay? So, if we want to do rise divided by run, make a quick graph. If you're taking the actual ACT, which all of you are going to have to in April. Is it April this year or March? One of those two. Okay? Or -2. Hey guys, rise, -6, divided by the run. There's 5 and there's 4, so that's +9. Right? Now, a lot of us did, so what I do want to talk about really quickly, Dalton, is a lot of times we learned that strategy of x or y2 minus y1 divided by x2 minus x1, and personally, that's my least favorite strategy. Does it always work? Sure. But the reason why I don't love it is because we so often mess up, we put a superscript, a square, instead of a subscript. It's really easy to do that. It's really easy to forget if it's supposed to be y in the numerator or x in the numerator, things like that. So what I like, does anyone remember what I actually really, really like? I like the change in y divided by change in x. Because then I don't have to sweat a ton of these details, right? Like it's naturally filtered out. Now, if you don't remember x versus y, start with what you do know. Walter, what do you know about slope? Rise divided by. And when I visually think of rise, that's the change in y. Divided by the change in x. And so what I do is I just look at this. Hey, to go from -2 to 4, what has to happen? Not +2, +6. Okay? When I look at the change in x, what has to happen to go from 4 to -5? So it's got to go from 4 to 0, and then from 0 to -5. So minus what? Minus 9. Done. That's it. That's why I like the change in y divided by change in x strategy. I don't have to sweat, because like over there, that's the other thing, subtracting a negative versus all those different signs, things like that, like it can get confusing. You don't have to use this strategy, but I do highly recommend just look at for the change in y and the change in x. You can also do it tabularly, right? So Dean, you did it with a table over there, but you did all that extra work when you could have just gone, we've got 4, -2, and -5, 4. Okay, add 6, subtract 9, change in y, change in x. That's actually my absolute favorite, is to set up as a table like that where they're just right next to each other. So slope. Once again, my big point is this. Is there only one way to solve this problem? There's not. There's a million different ways. Second, I want us to understand that you need to figure out what's comfortable for you, but always go back to the foundations. Go back to rise divided by run. Make a graph if you need to. But change in y divided by change in x is a little bit cleaner. Does anybody have an idea? So we have our slope, by the way. Does anybody have an idea how I could write this equation? Oh, I hate that I erased that. How would I write the equation for this line We haven't done this specifically, and when I finish drawing this, you'll see a problem, I think. Okay, so if I draw a line here, does anyone see a problem if I was trying to write the equation of this line? If I was trying to write the equation of this line, does anyone see a problem that I might have?
That it doesn't go to the origin.
So it doesn't have to go through the origin, but you're close. Say again. What about the arrows? It does go on forever, but I mean, if I'm writing the equation of a line, lines usually go on for forever, right? Okay, let me ask a different question. What's the normal equation of a line that we've done for forever?
Y equals mx plus b.
Here we go, Finney. Y equals mx plus b, right? Okay. So what's my m based on what we've already done? Negative 2/3. What's your question, Chelsea?
What's the other point? Show me the light.
What other point? Well, what does b stand for?
Base.
Not with a line. Hey guys, what's the name of this equation? It's the name of the equation.
Slope.
Slope?
Y intercept slope on the line.
What's the name of this equation? Slope what?
Intercept.
Okay, slope intercept form. Okay? So Finney, you were answering a question, but we need to slow down and pay attention to the question. Slope, and this b is my which intercept? Y intercept, okay? So notice it's neither of those points actually, if we do this route. And if I look at this, it looks like my y-intercept is 1, but that doesn't actually work. And so I want y'all to pay attention to this. I'm going to extend a little bit on what we've already done in class. I'm not testing you on it anytime soon, but I need you to pay attention to this. If I put 4 in, what should I get out?
2.
Close.
6.
Negative 2, thank you. If 4 goes in, negative 2 needs to come out. And if you do this work, negative 2 and negative 5/3 are not the same thing. So is that equation correct?
No.
No. Okay, so I just want to show you all something new that can help you in other problems. Again, I'm not testing on this yet, but it's good to be aware of this. So it's not actually crossing at a positive 1. It's close, but it's not exact. But here's something you could do. That's an invalid equation. Where did that equation come from?
Transformation.
100%. Yeah.
Transformation.
What transformations did I do?
Translation.
Translation to the...
X and Y.
Yeah, but translate left, right, up, down.
Right and down.
Oh, translate right, 4, and down 2. So that equation could work. I want you, actually, before I put it up here, I want you to work with your group to figure out what the equation would be if we use that point. Okay, so I use this point for my transformations. Talk with your group, write it on your vertical surface. We got 60 seconds to come up with the equation that would be based on the other point. So think about how we would apply that.
Erase everything.
Yeah.
So talk with each other, come up with an answer.
Where
Let's
did,
actually talk, right, KB?
where did you get negative 2 over 3, like the A part?
Well, remember, that's our slope. So with a line, that A is my slope.
Okay, so we can use that for the same equation.
Correct, the slope, the A would still be the slope of negative 2/3.
Oh,
I'm not normal.
Have you talked to your group at all yet? Because it seems like Abby's got some ideas already going up on that board, bro. Like, just kidding, I got no clue, but I got a group member who has an idea, and I'm not even talking to them.
We don't know.
Abby literally has an idea. Talk, bro. Golly.
We're doing the opposite. Points, get the other points.
We got the most communicative group ever right here. Okay,
You gotta actually have.
we gotta talk today. We're gonna be covering some important ideas.
This is X equals equal to 4, right?
It's not.
Yeah.
Okay, first of all, yes, I think it's gonna be positive 5. If it's originally a negative 5.
You like, I'm not explaining it, but I
And then 4 would
Okay,
be,
let's work on this a little bit.
That
it'd be 4 plus 4.
Sure.
Let me write that. Yeah, it would still be plus 4.
Okay.
Uh,
Why does those plus 5 go to left 5? I think that's where you're. Because so horizontal, remember, it's always the opposite. Okay. All right. So let's talk about this one. All right. So this time, to get to this point, what translations do we have to have? What translations do we have to get to this point? We have to have left 5 and up 4, right? Left 5 and up 4. Someone, I think Rihanna, you were asking earlier, like, where did the negative 2/3 come from? How is that your A? And we just have to remember this is a line. So what is the A in a line? That's our slope. That's it. Okay. So keep in mind that the A in a line is our slope. And so I'm actually going to rewrite this a little bit. But yeah, so not rewrite this, but rewrite some things we've looked at. So yeah, it's our slope. And then here's the thing to remember, is I do have an x minus 5 over here, but y'all said x plus 5, and y'all said x plus 5, and y'all said x plus 5. So why are all of y'all saying x plus 5 when it's supposed to be to the left?
It's switching to.
So don't forget, everything horizontal is the opposite. So remember how the equation, the transformation is x minus h plus k? So if I want to go left 5, it needs to be minus a negative 5. That's a cleaner way to explain it as well. When we were talking about that earlier, Chelsea, you're subtracting a negative, right? And to subtract a negative, what do we end up doing?
We're making a positive.
Well, it becomes a positive. Subtracting a negative makes it positive, okay? And so, what I do want to show you is this is the equation based on our transformations. This is the traditional equation that we write for this type of line. But it's saying the same exact thing. You don't have to memorize a whole new equation. X1 and Y1, that's just any old point. And to get to this point, I've got to translate to the left 5 and up 4. And then I have a slope of negative 2/3. So this is also, by the way, I do want you to notice, what do you need for this equation? You need a, what did I say x1 and y1 are?
The value, the intercept.
What values, like what are they, when we put them together, what are they called?
Point.
A point, x and y of a point. So we need a point and we need the
Slope.
slope, so this is called the point slope form of a line. That's it. But you don't have to memorize the point slope form, it's based on transformations. Okay, you do not have to memorize point slope form of a line, it's just transformations, as long as you understand A is M. Alright, let's continue with today. We're going to get back into Desmos, so I'm going to do a quick recap of some details of the vertex form and give you all some practice. And so we're on exactly the same proficiency scale concepts as yesterday. So let me get this pulled up. Is that where I have Desmos? Oh, I gotta actually log in. I had y'all log in, and I didn't even log in myself.
What's the code? FRMC.
Dude, you've already logged in before, right?
It made me log out.
Okay, when you log back in, it'll automatically have been saved.
What's that?
You need to find a
FR.
one person.
ZM. N, like N.
Don't do it yet. I need to show you how to log in without putting the code in every time. Thank you, Chelsea. I just need him to be able to log in without having to put the code in every time. Okay, so
You are logged in.
big ideas from yesterday. What did we find out that A does to the parent function?
You don't change the vertex. I mean,
Don't change the slope.
okay.
Okay, that A controls the concavity. In fact, when is the parabola concave up? When what is positive?
The
When
A,
A is positive. So when A was positive, the parabola is concave up. When A is
negative, concave
negative, the
down,
parabola is concave down.
like a frown.
Like a frown, that's exactly right. Okay, what did we learn about H and K?
They control the
X and Y.
X and Y, yeah, and the vertex.
Be careful, you just said X and Y.
Wait, no, the vertex.
The A changed the,
The A changes concavity. It does change the x-intercepts, but remember, H is not the x-intercept. Look at the board right now, what is my H value?
5.
H is 5. Where
They
do I see
changed-
that
Oh,
value of 5 up there?
X.
They changed the X vertex.
The x
Vertex.
value
Oh, value
of
of the
the vertex. Remember, x-intercepts are only where we intersect the x-axis. The H is the x value of my vertex. The K is what?
The Y value.
Of
The vertex.
Vertex. Because remember, H and K, those are the transformations we've already seen in the past, right? There's my parent function. There's my parent function. If H is 3 or 4, it was translated to the right 4. If K is 2, then it was translated
The right
Up.
2. Oh,
up
up 2.
K, up 2, right? So
Sorry.
there's my vertex, 4, 2. H and K are defining the vertex. And then we also finally looked at the line of symmetry. What controlled the line of symmetry?
The H.
The H. And I really liked, I even brought it up to my 4th block, I really liked the way that Leah said it. H is defining that line of symmetry. H is defining that line of symmetry. Please remember, like right now, H is -6, so what is the equation for the line of symmetry here?
X equal 8. I mean, H
X equals
K. I mean, H. Yeah.
H, which is
6.
-6. Notice it's a whole line. It's not just the number -6. It is a whole line. It has to be X equals that number to have the whole line. Because we're talking about every point that has an X value of -6. And so now where we ended yesterday was we ended looking at this set of practice for you applying these ideas. And so I'm going to give you all a few minutes to work through this. I know I think one group finished, but just work back again with your group if you were part of that group. But remember, the whole point is this. We can look at a graph and see the vertex. We can look at a graph and see the x-intercepts. We can look at a graph and see the line of symmetry. But now I want you to be able to look at the vertex form of a line and know some of those features. Okay? And so we already did this first one, so I'm going to go back over it with you. What is the vertex? So like if my equation is this top one, what's the vertex? Three, 4?
Well, yeah, negative. Negative.
Negative
Is it -3 or +3?
Positive.
It's positive, ain't it? Positive.
Why is it,
Yeah, it's fine.
why is it positive?
You gotta switch to X.
So we gotta switch, we need the opposite. One thing I will point out, this is something I highly recommend, and the students who do this always have a ton of success with it, and the students who don't sometimes have success and sometimes don't. So you can just be on the safe side and write the equation out every time. Remember, that's my vertex form. Remember how it's x minus h, and it's x minus 3. So literally, what is h here? Is h a +3 or is h a -3?
Positive.
H is a +3. K is a
Positive.
+4. So my vertex, h comma k, is 3 comma 4. That's my vertex. What's the line of symmetry?
Would it be H equals 3?
X equals 3.
Yeah.
We defined it yesterday as x equals h, right? And h is
3.
3, okay. What about the concavity?
Up.
Why is it concave up?
Because positive 4.
Because what's positive?
Well,
The A is positive.
Yeah.
Right? Notice that's about the A. So notice we can identify these features. And so here's what I want you to understand and hear me clearly on. On your test and on your demonstrated understanding, I'm going to give you a vertex form of the equation. I'm going to ask you to graph it by hand without a calculator. Because here's the thing. It doesn't have to be a perfect graph, but it needs to have that correct vertex. It needs to have that line of symmetry. And it needs to be concave
Up.
up. That's not a perfect graph, but it's at least got all those features. Notice by just taking the time to identify the vertex, identify the line of symmetry, and concave up, I have a pretty good picture of what that graph looks like. That's it. Identify the features you can so that you can sketch a graph all on your own. Okay? I need you to work on the next three. I'm going to give you all about 5 minutes to finish up those three. We're going to go over them, and then we're going to continue on to the next form of a quadratic. This is on slide 8, by the way. Let's talk about it and let's look at it really quickly. So I'm just going to use the ACEs work. And so a lot of us are getting there for sure. Does everyone agree with all of the vertices, the line of symmetry, and the concavity that we see up here? Is that the same answer that all of y'all got?
Yeah.
No.
Yeah, I was going to say, I think it was a -6. What else did you have different? That one? There is a negative here. Yeah, it's just hard to see.
It's kind of hard to run on that board.
Yeah, I told you this
I
board
figured we get tired.
sucks. Yeah, I hate this board. Okay? Yeah, she had a negative there. It just wasn't easy to see. Okay, everything else good to go?
Yeah.
Okay. So, yeah, I'm good with this. Just don't forget, a lot of this ties into the transformation ideas we've discussed in the past. You need to take the opposite with that H. That is the number one mistake students make, is they forget to take the opposite, right? So if it's x -3, the H is 3. If it's x plus 5, the H is -5. I do want to point out, I really like what we see over on the 9s. If you glance over there, what do the 9s add?
If the A is negative, if the A is negative, then concave is down.
Yeah, notice they didn't just put down or up, and I know I didn't ask y'all necessarily to do that, but it's a good idea to practice that, right? Concavity, down. Why? The A is negative. That's clear. That's evidence of why we have that going right there. I like the line of symmetry. X equals, -5, X equals H. That's good, strong evidence of understanding. Just a little bit more that you probably could add with the vertex, right? Just explaining where those values are coming from, ways you could do that. Providing that evidence is just writing above it. Remember, the vertex is always H comma K, right? If we take our equation, what was the first one, or the second one? -1/2 times x plus 5 squared minus 6. Could you label and say, hey, H here is -5, K here is -6? That's evidence of understanding. Writing out the vertex form above it, even that is evidence of understanding. So, you need to start thinking through, how do you know these things? Right? We got, almost every group got all these right. You gotta make sure you can explain how you got there. And really, it's just, what was the thought process that got you there? And so these are some more formal ways that you can provide that evidence. One thing I do want to remind you is, what do you have to put around every point? Parentheses. Guys, if you don't put parentheses there, you don't have a point. Okay? Alright, so now, let me go ahead and paste this. So we're going to go from slide 9 to slide 15. I'm going to restrict all of those. Okay? Now, we're moving into a new form though. What form of the quadratic equation are we looking at?
Standard form? Wait, what?
I was saying, what does it say up there?
Factored.
Factored form. Slide 9 is all about factored form. Now remember, we did talk about this. I told y'all at the end, why do we call vertex form again? Because you can see the vertex really easily, right? Like, that's the whole point, is that H comma K is your vertex. We talked about this one yesterday as well, though. Why do we call this A times X minus R1 times X minus R2? Why do we call this a factored form? Yeah, what do we do with factors? We multiply factors. Notice, those are being multiplied. Right? We don't name things randomly in math. There's a purpose to that naming. So it's called a factored form. Why? Because we are multiplying factors. KB, you alive back there? How do you engage it when your hood is up? 1, 2, you're looking towards the back of the room. So, factored form, right there. And so what we are looking at is a few different things. Once again, I'm starting you off with A. Alright? Any predictions about what A is going to control in this parabola? That A right there?
The vertex.
Okay, so thinking A controls the vertex. Any other predictions? A might control the concavity. I see Jaw going, yeah, I think that makes sense. Is that what you were saying? Yeah, okay, so we'll see. Right, so I'm not telling you the answer, but we've got this slider here. Move your slider back and forth. I need you to make a conjecture about how A affects the parabola. Once you're done with this, what are you going to do?
Move to the next slide.
Move to the next slide. When you're done with that slide, what are you going to do? Move to the next slide. I will point out, and I need you to note this, that as you move in this one, what am I asking you to look for here? The values of,
R1, R2.
right? So we found out H and K are the vertex. H defines the line of symmetry. In the last form, at least, A controlled the concavity. We need to figure out what do R1 and R2 connect to on this graph. So in the same way that H and K showed up specifically on that graph, R1 and R2 will also show up somewhere specifically. And so we need to be able to look at our equation and figure out from the equation, what's that graph look like, okay? So let's get to our vertical surfaces with our small groups, and let's figure out what A looks like in the factored form and what R1 and R2 look like. So let's get up, let's move to slide 9. You should be restricted, did it not restrict you? You should only be able to look at slides 9 and 14. That's weird, let me look at yours in a second. Alright, let's get after it. No, okay. I thought you were going further than that. Perfect. Alright. Come on, y'all. Let's talk together. Let's work together. Let's write some conjectures on that board with your group. And so I'm going to put the Desmos activity back up on the board. Yep. And we're going to talk through a couple of the things we're seeing around the room. Now, the majority of us have pretty much the same general idea. Now, I'll start with this. Everybody said that A is affecting the what?
Concavity.
Concavity, right? When A is positive, that parabola is definitely concave up, and when A is negative, the parabola is
down.
concave down. So the A has not changed from the vertex form whatsoever. Okay? So yes, and so that was actually something Walter was talking about originally. So I'm going to pull this screen down for a second. Walter also said, hey, A is changing the vertex. Now, what I want us to be careful about and remember is lots of things are being affected by every value. The question is, what is that A defining, right? So, I mean,
R2 is defining everything.
no, because as A changes, what's the only thing that doesn't change?
The vertex. I mean, the x-intercept.
The x-intercepts, right? Notice the y-intercept changes, the vertex changes, but the reason why is, as A gets bigger over here, closer to 2, what's happening to that parabola? It's what? Stretching. And so the stretch, this is going to get lower, right? Okay, so when A becomes negative, it's going to reflect. So the vertex now has to be above the x-axis, but again, as A gets more negative, it's being stretched, which is why it's changing, right? But what is A defining? A defines the what?
X value of the vertex.
No, the concavity. Benny, the thing that y'all wrote over there, A defines the concavity. All right? I think several said it, but I do really like the way this is worded, and I would say this is well worded, is when, yeah,
almost had it.
kind of. So the only thing I would say is the Y value of the vertex is negative. But you don't need to stress that a ton. Oh, wait. Yeah, this is all you need right here. When A is negative, the parabola is concave. Concave what? Down. That's it. When A is negative, the parabola is concave down. When A is positive, then what we should have is that the parabola is concave. When A is positive, the parabola is concave up. Okay, that's what we should have, right? So you should have those two details for sure. When A is negative, the parabola is concave down. When A is positive, the parabola is concave up. That is it. And because of that, Finney, and because of those stretches, it affects other things, but A is defining or controlling the concavity. Okay, so A is all about concavity. Now we need to look at x1 and x2. Okay? So, for one, and I think that the Kings had what a lot of us started with, and we just need to learn from this. Like, as I change R, what's changing? Or R1?
The vertex.
The vertex was changing, the y-intercept's changing, and x-intercept's changing, right? So, but remember, the question is not what is changing. The question is what is it defining or controlling, right? Right now, R1 is my what? Is 5. Yeah. R1 is 5. Where do I see that 5 on this graph? One of the
And the y.
x-intercepts.
Oh.
And why? Why
And the
would I
very
go
top.
right?
That's kind of luck. I'll explain why in a second. Nope, that's not what I want. Notice is 5 my y-intercept now.
No.
So 5, R1 of 5 is my, what? Where do we see that R1 of
Oh,
5?
x-intercept.
As an x-intercept, right? R2 is what? Where do we see that on the graph?
X-intercept.
As an x-intercept,
They
right?
both make, no, they both, never mind.
They're both, yeah, both affecting the x. Right now, R1 is 3. Do I see an x-intercept of 3? Yeah, ish. Do I see an x-intercept of -5, R2? Yes. Now, here's what I'm going to caution on, because even what I'm saying right now is not 100% mathematically accurate or precise, and he needs to learn from this, okay? So, it is true that R1 and R2 are controlling the x-intercepts. But I wanted y'all to see some language that Amaya was using, because she remembers some key language right here, okay? So I would say R1 and R2 define, right, the x-intercepts. So not quite the x-intercepts, and here's why I'll say that. Does anyone remember the two words that Amaya wrote up here that are very heavily connected to x-intercepts?
Can we say that question?
Well, what are the two terms that Amaya has up here that are very heavily connected to x-intercepts?
The zero?
Zeros and
Let's say root.
roots, okay? So I'm going to break this language down. I need y'all to pay attention to this. So if I have, if I look at this right now, my A is 1, my root 1 is 3, so x minus 3, and my root 2 is -5, so it'll be x plus 5. So right now, my roots are 3 and -5. If, trying to look for a different color. Where's that? There we go, that worked. If I now write this as x minus 3, or f of x, equals 1 times x minus 3 times x plus 5, the zeros are x equals 3 and x equals -5. Those are pretty much identical, so what's the difference between a root and a zero?
Huh?
Where's origin?
So this has roots 3 and -5. This has zeros x equals 3 and x equals -5. Why am I calling them roots here and zeros here? What's the difference?
I guess because the zero is taking like the x place. So it's like, for instance, it'd be 0 and negative, like, I don't know.
Close. It's not taking the x place. The x is 3.
Taking, well, I don't know. Is it taking the y place?
It's taking the y place. A zero, why do we call it a zero? We call things zeros when the y is equal to 0 for the function. Zeros are the x values where the y is 0. That's why it's called a zero, because literally the y is 0. Notice those zeros are going to be the same for the roots, but notice, is this even a function?
What is?
What do you have to have a function? You have to have
Equal sign.
an equal sign, yes, but there's two big things. An I and an O.
Input and output.
An input and an
Output.
output. What is this missing?
The output.
It doesn't have a single output, right? So what do I call this thing? There's no equal sign, there's no inequality, it's an...
Not a function.
It is not a function, you are true, but there's an E word that can describe this thing that doesn't have an equation, or an equal sign. Huh?
Expressions.
Uh-huh. Roots are for expressions, but notice the roots and the zeros are the same. Let me say it one more time. Jay, you awake back there, Chelsea?
Yeah.
You awake? I've only been talking for like 5 minutes. I don't know how we fell asleep that quick. Good talk. All right, so roots are for the expressions, zeros are for the functions. Please do note they are the same values though, right? And so why in the world do you think our factored form is a times x minus r1 and x minus r2? Where in the world is r1 and r2 coming from?
The root.
Yeah. R literally stands for roots. And notice how many roots do we have?
2.
We have 2 roots. So R1 and R2, these are just the 2 roots. That is why we use an R there. Okay, so when we say R1 and R2, we're talking about our roots. That's it. But final detail, and this is actually really, really important. We still haven't gotten to x-intercepts yet. What does every x-intercept have that we're missing as we're talking about roots and as we're talking about zeros? X-intercepts are, because like it's not just 3 and just -5. What are the x-intercepts?
-5, -2.
It's -5 what?
And positive 3.
Say again. -5 comma 0.
Oh.
Remember, x-intercepts are points. We've got to remember x-intercepts are points. So -5, 0, and 3, 0. If you're talking about an x-intercept, it has to have the root, and for every x-intercept, what's the y value?
0.
0. You've got to remember, for the x-intercept, you've got to have a point. Please make a note of that when you do your notes in a second, that x-intercepts are points with y equal to 0 every single time. X-intercepts are points. Now hold on, Didi, I haven't even given you the factored form yet. Alright, there's one last thing. We still have to talk about the axis of symmetry, but clearly several of us need to go ahead and start taking some notes before we forget everything, because we're already trying to fall asleep on me, and I don't want that to happen. So here's your factored form. Again, one last thing to remember with that line of symmetry. It's got to be in the middle of the roots. So that h is just the average of our roots. So if we're trying to find that line of symmetry, average your 2 roots, and now you have your line. X equals whatever the average of the roots are. Need y'all to please pay attention. Sounds like announcements are done. Let's talk over a couple of things. So first thing I do want to point out, what's the easiest feature to see right away?
The graph.
That's a whole graph. What feature is the easiest to see right away? Thank you, concavity. So like this function is going to be concave up. Why?
Because the positive.
What is positive?
The A.
The A is positive, okay? What about the second one?
Concave down because the A
Concave
is
down,
negative.
because A is negative, right? It's negative 1/3. What about this third one here?
Down.
Down, because A is
Negative.
-5. And what about the fourth one?
Positive.
Positive
Concave
because
up.
A.
Okay, A is positive. So I'm good with all of our concavity, but let's talk about these roots for a second, because I need us to pay attention to this. There was a lot of debate for a lot of groups about whether we should do the opposite, right? I need y'all to pay attention. This is why I write my factored form or my vertex form above or below my equation every time. Because when I look at it, it's already x minus r1, right? So what does r1 have to be? r1 has to be positive 3, right? So did I need the opposite?
Yes.
Yeah. Remember when it's x minus h, x minus r1 and x minus r2, yeah, I need the opposite. Okay, what about r2 here? In order to go from minus r2 to plus 7, r2 has to be a
Minus 7.
negative 7, yeah, minus 7. Be careful, minus is an operation, negative is the sign, but notice, y'all did a great job right here of noticing it's 3 comma 0 and negative 7, 0. Notice we have how many x-intercepts?
2.
2. We write it as 2 points. One of the more common mistakes students make is they write their roots like, or their x-intercepts like that, but that's 1 point. We don't have 1 point, we have
2 points.
2 points. Be careful and make sure you put it as 1, okay? So 3 comma 0, negative 7 comma 0. I'm going to come back to the line of symmetry in a second. So this next one, right? What are the roots? Do we agree? Negative 8, 0, and 1, 0?
Yep.
Right? So I need the opposite of positive 8, so negative 8. Opposite of minus 1, so positive 1. Cool. Next one, do we agree the roots are negative 2 and negative 10?
Yes.
So negative 2, 0, comma, and then negative 10, 0. Okay, but the last one here, did that last one drive anybody else a little bit bonkers?
No.
Nobody?
No.
Okay, did y'all agree then that it's 3, 0, and 0, 0?
No.
I mean, I just put 3. I didn't like.
You just put 3 one time?
But it's been square, you know, square.
It's
Yeah.
0, 0.
Okay, so here's what I want y'all to think about. Someone mentioned that this is being squared, isn't it? How did I rewrite x minus 3 squared then? X minus 3, and then what?
X minus 3 again.
Times x minus 3. I think this makes it a little bit more clear. I still have how many roots?
2.
2 roots. What are those 2 roots? R1 is 3, R2 is
3.
so those roots are the same. Notice we have 2 roots, they're the same. So what is my x-intercept? 3 comma 0. Remember, an x-intercept has a y of 0. And so, hold on. So, how many x-intercepts does this actually have? It only has 1 x-intercept. It has 2 roots, only has 1 x-intercept. I would point out you could also pretend that there's a plus 0 here, and now this is a vertex form as well. So that x-intercept is also the what for this quadratic, this parabola? Hey guys. That x-intercept is also the vertex, so it would look like this. That's my vertex and x-intercept, and it's concave up, is what we said. So that's roughly what that parabola would look like. So it's important to notice, we'll talk about something called double roots later, but it is possible to have the same x-intercept. Again, you can also even have sometimes when you have no x-intercepts, but you still have 2 roots, so hold on to that idea. The last thing I want to talk about, line of symmetry, we'll just talk about briefly, and we'll practice graphing these tomorrow. So how did this negative 2 come into being? Well, so first off, so hold on 1 second. Line of symmetry is always x equals h. So hold on to that, because Rihanna, you wrote h equals for that line of symmetry, right? But the line of symmetry is x equals h. Whatever h is, that's what x is. And we talked about, hey, h is the average of my 2 roots. Be careful with your signs, right? And so I'm good with negative 2 here. So x equals negative 2. But let's come down to here. And so I will say I saw someone put negative 5 here maybe, or negative 4.5. This should be negative 3.5. But notice I need the middle of negative 2 and negative 10. Negative 2 plus negative 10. No, it's adding a negative, subtracting. So if I have negative 2 and I go 10 more negative, I'm going to have negative 12. So what is that? Negative 6. So be careful, that's my line of symmetry here. So notice h does equal negative 6, so my line of symmetry is x equals negative 6. But all it is averaging those roots. Yes, Finney?
Where the function doesn't have an 8, would it still be calculated down as the x is negative?
If it doesn't have an a, it actually still has an a.
X. 1.
That understood to be 1. Even if it's not written there, it's understood to be a 1. So good question on that one though, Penny.